Hello cyber enthusiast. Welcome to our third lesson. In this lesson, we'll look into setting up and using Wireshark, basic network scans using the Nmap, and understanding and using VPNs. So let's jump into our first video. Wireshark is a powerful network protocol analyzer that allows you to capture and inspect the traffic on your network. In this tutorial, we'll cover the basics of Wireshark and unveil how you can use it to gain valuable insights into your network. Let's dive in. To set up Wireshark, you need to download and install the Wireshark from wireshark.org. Check the latest version for your operating system and follow the installation prompts and set up Wireshark on your machine. It's not a very heavy installation procedure, so you can just follow the instructions and get it set up on your machine. Once you have the Wireshark set up, just open and select the network interface you want to monitor. Click Start to begin capturing the packets. Let's have a look like how it may look like on the actual interface. Over here, I have the Kali emulator running. I have opened the terminal and I'm typing the command Wireshark. Once I open it, you may see an interface something like this. It will ask you to select the network interface that you want to monitor. In my case, I am selecting the Ethernet interface. Once selected, this will start recording all the requests that go through the Ethernet port. There are 3 buttons which says stop the capturing of packet and restart the current capture. It also has something called as display filter, which we can apply to check what kind of protocol we want to filter or what kind of port we want to filter, so on and so forth. So this is the basic interface of Wireshark. Let's capture some packet and try to dissect them. Now as you can see, there are a lot of packets that are getting exchanged between our system and over the net. Wireshark is trying to capture a lot. You can see a lot of TCP duplicate acknowledgements. You can see a lot of packets are getting exchanged from certain sources. So let me try to simplify this. Now there are 2 ways. Either I can stop the scan and then save all of these packets and try to analyze them offline, which is Wireshark's feature is to capture the packets online, save it and further analyze it for offline analysis. Now the analysis could be done for various reasons which we will be discussing in the further video. But for the time being, I'll just be trying to show you the capability of Wireshark. Over here, we can stop the button, we can stop the scan, we can reset the scan, so on and so forth. So these are few controls over here. So I am going to visit a website which is a testing website to test for the exchange of information between my system and the server. And let's see if it's trying to capture it. Now to capture such packets, I have to use a filter which is called as TCP.port, because currently when I was trying to exchange information from this site, it was done on HTTP via port 80. Now if you have a look at this result set, you may be able to see there are a few exchanges that happened with this specific port. There are more such filters such as frames. If you are trying to have a iframe or a window frame popped up, we can also search with domains like frame that contains. So there are multiple filters as such. Frame contains, say, xyz.com. If I try to search it in this way, it will try to search all the frames which has this kind of domain in it. In our case, the domain was vulweb.com. Let's try to filter such packages and see if we had few. Yes, we do have 4 of the packets that were sent or received from this specific domain. In this way, we'll be able to filter out all the packets. We can go ahead and stop the scan and we can save the scan with some certain name. So say let's talk about the vuln web, and then we'll save it with any name that we want to. Further, we can go ahead and analyze each of these packets and see if there was any information, what all information was transferred. More to it, it has got some other information over here, like what was the destination, what was the source, what was the type of protocol being used. Now over here, say we have the length of the packet and checksums, what kind of checksums were used, was it even getting verified? It says unverified. If we talk about the TCP metadata, it has everything like the source port which was opened, and the destination port, as I've suggested, it was on port 80 because HTTP connects on port 80 by default. Now looking into it, we do have the sequence numbers for the packet exchange that happened. And yes, in this way, you can go ahead and try to analyze the metadata you are trying to expect from a packet. Let's try to see the real world scenarios associated with the usage of Wireshark. Capturing the packets during the incident. Many times we see there is a slight delay or latency on the website that we are trying to browse. Now, the website's admin can start the Wireshark and start capturing the packets and report the connectivity issues around the transfer of package. It could be due to anything, something like a delay in acknowledgement, or maybe the DNS resolution is not happening properly, due to which there is a latency that is appearing on the client side. This is one of the instances where Wireshark can be useful. We can also try to analyze the TCP conversations, such as what is happening when there is this three-way handshake happening. Are the acknowledgements received on the client side properly? Are there any abnormalities in the conversations? We can check for the, now many times, as we know, that until unless we don't get an acknowledgement on a TCP communication, there is an automatically retransfer of data packet from the source to client or client to source back. So due to this, there could be a retransmission that may cause the delays and unexpected resets. Now, we can also apply filters like TCP analysis. Now this is one type of filter that we can apply and see if there was any kind of delayed acknowledgements. So this can also give an indicate the latency affecting the communications. Now we can also try to find out the host which have high response times in TCP conversations. These hosts may be experiencing delays due to multiple reasons, which can be one of the reasons why the issues are getting reported for the delays. Now these are few of the scenarios, mostly around the TCP. There could be many other things for which we can utilize the Wireshark. So I'm trying to make it a bit concise here. So as we wrap up our journey with Wireshark in action, remember that network mysteries can be complex, but with the right tools and techniques, they can be unraveled. Wireshark empowers you to be the detective of your own network, ensuring its health and security. Thank you, and meet you in the next video.